In this video, I will show you how to reclassify data points that were misclassified or for cleanup purposes. We do the majority of the cleanup automatically during auto-classification. However, if you find that the cleanup is insufficient, you can manually reclassify points or use the automatic cleanup tool. All manual reclassification follows the same basic operation. First, you draw a polygon, rectangle, or circle around the points that need to be classified. Then you select the class you want to reclassify it to. When you draw a shape in side view, the points will be reclassified using a horizontal depth. This is useful for reclassifying manways and nozzles on the shell. Simply draw a circle around the manway or nozzle and reclassify the points to others. On the shell, I typically look at the 0 to 6 foot range when cleaning up. Another area you may want to pay attention to is the floor to shell weld. Sometimes you may need to reclassify shell points in this area to floor. For objects that can't be cut cleanly from the side view, you can reclassify them by drawing a shape in top view. This reclassifies points using a vertical depth. Simply draw a polygon around the points you want to reclassify, and then select the class you want to reclassify it to. On the floor, I typically only clean out the sump. This method can also be used to clean up manways and nozzles on the roof. The amount of cleanup you do will depend on your project requirements. Typically, I like to run the analysis and then come back to do cleanup as needed. If the floor has a lot of noise due to water or product, you may want to look at 1-inch slices and reclassify any points that are not part of the floor. You can also use the automatic cleanup tool. This tool works by fitting a surface to the data and then trimming data beyond a threshold from the surface. The first parameter determines how to fit the surface to the data. For example, if you want the surface to follow the lowest part of the floor, you will want to use a low percentile like 1%. If you are trying to find the highest part of the floor, you will want to use a high percentile like 99%. If you are trying to find the middle of the shell, you will want to use the median or 50%. The second parameter determines how big of a surface you want to use. A larger surface will represent general trends, while a smaller surface will represent local trends. The third parameter determines if you want to cut off everything above or below the surface, or above and below. For example, if you want to remove nozzles and manways from the shell, you will want to remove both inside and outside points. However, if you are trying to remove piping from a berm, you will want to only remove above points. The last parameter determines how closely you want to trim from the surface. Depending on the amount of noise in the data, you may need to use a higher threshold in some cases. For larger scale cleanup in berms, you will want to use a larger cutoff threshold. The default parameters are what we have found to be optimal for each type of cleanup scenario.